1247 centimeter and 1516 centimeter were the lignin degradation region that were seen to degrade, and 800 to 800, like 427 to 847 were the glucan region that were seen to increase, depicting that the glucan must have increased. The maximum yield of bioethanol was observed in fungal solid state fermentation, which was around 3.5 to gram per liter. So this is the future perspective, where we can use nanometal catalysts for pre-treatment. Genetic engineering are involved for improving the microbial strains, and pilot scale production, bioethanol production could be done. So these are the references, my research publications, and the certificates. Thank you.
Now the session is open for discussion. So uh, during presentation itself, uh, uh, Dr. Subodh Sinha already asked some question, but some more queries you want to ask from Akanksha.
Yes, Kancha, as I
Dr.
said,
Sinha.
yes. Uh, uh, as I said, you didn't have any reference. So, what is your, final conclusion, the take-home message? I mean, if suppose you have to again work as an independent scientist on this aspect, how can you take this work further?
So first of all, we can change the pre-treatment techniques. Like we
Why?
can go for different pre-treatment techniques.
Okay. Why? You don't want to use the techniques which you have used?
So obviously we can go for these techniques, but we can go for better techniques also. Like ball milling method is one such techniques which have been seen to enhance the lignocellulose degradation.
Okay.
And since it was not available here in our lab, so
Okay.
we can work on ball milling technique.
Okay.
Radiation technique could be observed, sir. Radiation technique is also known to degrade lignocellulose to a very great level.
Mhm. So you said you can also go for the future prospect of the work. You can go for the
Yes,
genetic engineering. Any
yes, sir.
idea how can you engineer these micro?
Yes, sir. So different chemical reagents are also being used in different laboratories that are causing mutagenesis within the labs. And for sir genetic engineering, we can alter the DNAs at genetic level, but mutagenesis is being caused by different chemicals in different labs, where after mutagenesis the fungal strains are seen to degrade to sacrifice more level of lignocellulose than the normal fungal strains.
So what would be the basic difference between when you are modifying your microbes using some chemical mutagen and then uh, when you are using some kind of recombinant DNA technology? Which one would you feel or would you think better for manipulation of the microbes?
So I think genetic engineering would be better.
Why?
So because for mutagenesis, for genetic engineering, we will so we have into our mind that what we are doing, and for mutagenesis, we will have to constantly check on that if the mutation uh, has occurred or not. But for genetic engineering, we are either installing something into the microbes, or we are altering it on our level, sir. But mutagenesis is like, sir, it's experimental level, sir. Mutagenesis may we'll have to wo- so all the time
In
we'll have to
mutagenesis, the
go on.
simple answer is when you use chemical mutagens, the mutation would be random. it can mutate any genes.
Yes, sir.
But in recombinant DNA technology, if you know the gene to be manipulated,
Yes,
that
sir.
manipulation can be very, very targeted.
Yes, sir. Yes, sir. That could be targeted.
Okay, so I think your work has also a commercial aspect. So
Yes.
have you thought of commercializing uh, the techniques and the strengths that you have identified? That angle, whether you have discussed or because this is you talked about the very burning issues,
Yes, sir.
and if you think that your strengths are efficient and your techniques or the process are efficient, you can contact and go for commercializing it. So, have you thought of about this? You haven't thought about that, right?
So we can
So,
go for it.
no, we can go means you have to go, whether you
Yes,
have
sir. Yes,
thought
sir.
about it or not. Okay. So these are the questions related with your work, but I also want to know about your basic understanding. You have used a lot of techniques to see the structural variation, uh, FTIR, this kind of thing. So, are you well aware about its principle? Why you have used these tools and techniques?
So although all these instrumentational facilities have been performed out of a lab, uh, but
Okay.
but yes, sir, I'm aware of the principle and the requirement
So,
that.
so whether you have analyzed the result by yourself.
So yes, sir, I have also studied the result myself.
Okay, so you are aware about the analysis part, right?
Yes, sir, part of it.
Okay, all right. If any other faculties or want to ask, they can ask. Or we can also discuss if we have set of questions from the other examiner, evaluator, Dr. Birendra.
Dr. Sinha, actually, you have already asked the same type of question also asked by another examiner.
Okay, then
So,
it's fine. It's fine.
any
No
more
problem.
question from audience?
Yeah.
Anyone can ask, because this is in hybrid mode. This is not totally online. We have many people, many faculty members, research scholars are here.
Yeah, yeah.
So
They can ask.
yes, we can ask.
Yes, sir. So first of all, ethanol is used in pharmaceutical industries, and sir, it is used in biofuel industries for transportation. Ethanol is being blended in with petrol for transportation. Sorry, sir. So I think this is different. Thank you, sir.
Uh, okay. So for second presentation, actually the entire uh, session is actually recorded already. See, for the recording, another link is there. So just 2 to 3 minutes break for the recording in a new link, and then we immediately start the second presentation by Tripti Neha. Okay.
So have you sent
So
the another link?
Akanksha, you may uh, dissociate from the session for the time being, and Tripti, you may join.
Thank you for joining us.
Same link.